Alright, next example. Says find r if s is equal to 15, t is 32, and the measure of angle r is 40. Round to the nearest tenth. So again, probably going to use the applied law of cosines to solve here. I'm trying to solve for r, so taking what I know, I will have r squared, the side I'm trying to solve for, squared, equal to the other two sides I know squared, so I'll have 15 squared plus 32 squared minus 2 times those two sides, so 15 and 32, multiplied by the cosine of the angle across from the side I'm trying to solve for, which will be 40. Okay, simplifying here, let's take 15 squared plus 32 squared. So 15 squared plus 32 squared is 1,249. Okay, once we have that, let's take that minus 2 times 15 times 32. So 2 times 15 times 32 will give us 960, and we'll leave the cosine 40 there, and this is equal to r squared. Now that we have that set up, we can square root both sides, and we'll have r is equal to the square root of 1,249 minus 960 cosine of 40. Remember to type that in a calculator. It would be square root parentheses 1249 minus 960. Cosine kicks out its own parentheses, 40 close, and this approximate value, once you plug that in our calculator, would be 22.7. So again, this is applying the law of cosines. Alright, let's try another example. Next one says find the measure of angle L round to the nearest degree. So now we're going to find an angle using the law of cosines. So L is my angle in focus, so that means 24 is the side that's going to be out. Okay, so we have this setup. L squared is equal to m squared plus n squared minus 2mn cosine of L. Information that we do know: 24 squared is equal to 27 squared plus 5 squared minus 2 times 27 times 5 cosine of L. So far so good. Simplifying further, 576 is equal to 754 minus 270 cosine of L. So this is just simplifying all of those values. At this point, if we're trying to solve for L, I would probably get rid of the 754, and that's what we're going to do here on the next slide. Negative 178 then is equal to a negative 270 cosine of L. These are really being multiplied together, so we should divide both sides by negative 270. And then now that we have cosine of L and I want to get just L by itself, we can simply use the cosine inverse to get L by itself. So a final setup will be the cosine inverse of 178 over 270 equals L. And of course we plug that into our calculator and solve, and we have L is approximately 48.8. So that is solving for a side, a cosine, or side, or an angle, excuse me, given three sides using the law of cosines. Repeating final answer, the measure of angle L is approximately 49 if you're going to the nearest degree. Alright, let's go further and do this one again. Find the measure of angle P around to the nearest degree. So angle P is what I'm trying to solve for. That means that 2.9 will be what I'm going to focus on. So I will have 2.9 squared is equal to the other two sides squared and added together. So 3.1 squared plus 1.3 squared minus 2 times those two sides, 3.1 and 1.3 times the cosine of P. Okay, if I fit it on the screen there. Simplifying then, 2.9 squared will be 8.41. So I have 8.41 is equal to 3.1 squared plus 1.3 squared is 11.3 minus 2 times 3.1 times 1.3 will be 8.06, and then cosine of p. I will subtract 11.3 on both sides, so I have 8.41 minus 11.3. I'll end up with negative 2.89 is equal to a negative 8.06 cosine of p. Divide both sides then by a negative 8.06. We will have the cosine of p equal to 0.3585, and then taking the cosine inverse of that value will give us approximately our value for D of 69 degrees. So again, P is equal to the cosine inverse of 0.3585, and then the approximate value of P, of course, is around 69 degrees. Okay. Next example. It says aircraft from the diagram of the plane shown determine the approximate width of the wing round to the nearest length. So we have an isosceles triangle with an angle of 50 degrees. So we have 20 here, and we want to determine the approximate width of each wing. So we have the width here, kj. So we're trying to solve for kj. And if we put a variable there, we'll call it x, we could probably we can use the law of cosines to solve. So given that information, we know that we have a couple things. Kij is an isosceles triangle, so Ki is equal to 20, and then the two angle measures have to be the same. So if this is 50, we can also divide and show that both of these are 65, and that'll help us out significantly. So now it says use the law of sines to find Kj. We could have also used the law of cosines. We'll go here a little easier using the law of sines. I'm okay with both solutions. The sines given to us will be the sine of 50 over kj is equal to the sine of 65 over 20. Then we cross multiply and solve, divide both sides by the sine of 65, and kj then will equal approximately 16.9. So we'll use the law of sines here. We still could have done things with the law of cosines, but with less work now, we have using the law of sines. So I guess the point would be, anytime you have the ability to use the law of sines to solve, go with that. Okay, and the width of the plane, obviously, that wing, as we just said, 16.9. Alright, here's our last question that we have. It's going to be a couple slides. It says solve triangle PQR round to the nearest degree. So solving was the same type of idea we had with the right triangles in trig from the other day. We need all three sides and all three angles. So, and there's definitely a pattern that we have to follow to solve for all of these. Given all of the sides, we can use the law of cosines to solve for one of the angles, and then once we have one of the angles, we can use the law of sines to solve for the other angle, and then we can use the fact that three angles of a triangle add to 180 degrees to solve for the last. So it's a three-step process to solve for a triangle. In this particular one, we're going to use the law of cosines to solve for the measure of angle P. So we have this set up for the law of cosines. We have P squared is equal to R squared plus Q squared minus 2PQ cosine of P. Plug in the values that we know. So this is semi-routine now after doing this a couple times. And solving, simplifying and solving. Okay, subtract 130 on both sides. Divide by negative 126 on both sides. Take the inverse of the cosine, and we get the angle for P as approximately 58 degrees. So now we have angle P as 58 degrees. Given angle P is 58 degrees, and the fact that we have all the sides, we can now use the law of sines to solve for the other. So refer back to your picture. What we can do is use the law of sines to find the measure of angle Q. And if we know the measure of P, and we know the sides P and Q, which we do, we can plug in the information. Take sine of 58 over 8 is equal to the sine of Q over 7. Cross multiply. Okay, and use the sine inverse to figure out the angle for Q, which is approximately 48, and by the triangle sum theorem, which means that all the angles add up to 180 degrees, we can take the other angles, subtract them from 180, and give us the third angle for R, which is approximately 74. So solving a triangle is similar to the trigonometric ones we did with the right triangles, except now we have to do the law of cosines first, the law of sines to follow, and then lastly using triangle sum to solve for the last angles given. And they have the angles listed there at the bottom, PQ and R. Alright, that ends the lecture for today. Problems that we are going to look at in class will be from page 586, 1 through 42. Thanks for watching.